Hi all, welcome back to my YouTube channel. This is my first video on probability for VCE, IB or other international examinations. Let's see. Sample space and probability. Sample space and probability. The outcome of a random experiment is uncertain but exists in a set of possible outcomes. The epsilon, known as the sample space. The sum of the probabilities of all outcomes in epsilon is 1. The set that describes an event is a subset. As an example, consider a random experiment as a roll in a die. Epsilon is, we know that 1, 2, 3, 4, 5 or 6. If we toss a coin, what is it? It is either tail or head or tail. Then what is the event? It's a subset of this silent or the sample space. As an example, getting an even number. If A is an event, getting an even number, A contains 2, 4 and 6. Okay. Now, if the event A is impossible, the probability of that event is 0. The probability of A is equal to 0. If the event is certain, the probability is 1. Therefore, the probability of an event is always in between 0 and 1. Okay. For equally likely events, the probability of the event A is the number of elements in A divided by the total number of elements in the sample space. Number of elements in A divided by total number. Okay. For empirical probabilities, the relative frequencies probability A, the number of events A occurs divided by number of trials. We will discuss these things in details later. Okay. When an experiment has only two possible outcomes, they are said to be complementary. That means the complement event of A is denoted by A dash. That means the probability of A plus the probability of A dash, the complement of A, is equal to 1. Therefore, the probability of A dash is equal to 1 minus the probability of A. Then the addition rule of the probability. The addition rule of the probability is the probability of A union B can be written as the probability of A plus the probability of B minus the probability of A intersection B. Okay. Let's, however, the A union B, the union A union B includes all outcomes in either event A or B. That means the total outcomes. The intersection B, A intersection B includes all outcomes in both event A and B, the common elements. Similarly, we will go to mutually exclusive event. What is mutually exclusive events? Cannot both occur at once. That means, therefore, there's no intersection. As an example, if A is an event like this, B is another event, it doesn't have the common region for A and B. Therefore, they are mutually exclusive. In probability, the probability tables, the Carnot map, events. Venn diagrams and tree diagrams are really useful. Okay, the Carnot map or to a table. What is it? If there are two events A and B, but we know the complement events are A dash and B dash. Actually, the Carnot maps contains the probability of A and B dash, A dash and B. However, this row contains the probability of A. This is the probability of A dash. Or then we can write the probability of A can be written as the probability of A intersection B plus the probability of A intersection B dash. Similarly, A dash, B dash. Finally, this one is equal to 1. The Venn diagram, if we consider, we know that this is the common region, the probability of A intersection B. This is the region, the probability of A but not in B. That means the probability of A intersection B dash. This is the probability of A dash intersection B. The outside is the probability of A dash intersection B dash, where dash represent the complements events of the complements of A and B. Okay. Now we will go to the tree diagram. The tree diagram, what is tree diagram? There are two events, A and B. B occurs after A. The first one, the probability A or A dash. This one is the probability of A. This is the probability of A dash. Then this one, branch or the tree diagram, represent the probability of B after A, or then normally we write the B given A. This one is B dash given A. This is B given A dash, or B dash given A dash. Okay. Let's see the conditional probability. Now, the conditional probability that event B occurs given that A already occurred is written by the probability of B given A. However, we know that if you go back to this one is, if you go there, the probability of A times the probability of B given A is equal to the probability of A intersection B. That means this is the probability of A intersection B is equal to the probability of A times the probability of B given A. This is called the multiplication rule of the probability. Next one is the law of total probability. Actually, the law of total probability is the probability of B is given by the probability of B given A times the probability of A plus the probability of B given A dash times the probability of A dash. Or the probability, or if you want to write the probability of A, what is it? The probability of A given B times the probability of B plus the probability of A given B dash times the probability of B dash. This is called the law of total probability. Now let's consider this example. The probability that Tom needs to fill his petrol tank this week is 0.4. If he fills his tank this week, the probability that he will need to next week is the probability next week given that this week is 0.3. If he doesn't fill his tank, the probability that he will need to next week is n given t dash is 0.9. Draw the tree diagram. If we draw the tree diagram, the first one is either t or t dash. What is t? 0.4. The next one is no, n dash. No, n dash. He wants to fill or not. This is the probability of n given t. This is the probability of n dash given t. This is the probability of n given t dash. This is the probability of n dash given t dash. Okay, these are given probability of n given t is this is 0.3. Then we know that this is 0.7. N given t dash is 0.9. Therefore, this is 0.1. However, this is 0.6. Now we asked to find the we asked to find the probability t and n. T and n means this one. This one. T and n is the probability of t times the probability of n given t. 0.4 times 0.3 is 0.12. T dash and n is this one. 0.6 times 0.9, 0.54. The probability of n, we have to use the total probability rule. The probability of n given t times the probability of t plus the probability of n given t dash times the probability of t dash. Now n given t is, we know that 0.3 times 0.4 plus n given t dash is 0.9 times 0.6. 0.12 plus 0.54. This is 0.66. Next one, we asked to find probability t union n. We know the total probability rule. The probability of t union n can be written as the probability of t plus the probability of n minus the probability of t intersection n. Probability of t is known, 0.4. The probability of n is 0.66 minus t and n is 0.12. 0.10 minus 0.12 for 0.84. The next one is independent events. Independent events. Two events are independent if outcome of one has no effects on the outcome of the other. Then the probability of B given A can be written as the probability of B, and the probability of A given B can be written as the probability of A, because they are independent. Okay, we know that the probability of A given B is equal to the probability of A intersection B over the probability of B. However, we know that if A and B are independent, then the probability of A given B can be written as the probability of A. Therefore, the probability of A is equal to the probability of A intersection B over the probability of B. Therefore, the probability of A intersection B is the probability of A times the probability of B. Actually, if A and B are independent events, the intersection of the probability of A and B is equal to the probability of A times the probability of B. Okay. Now let's go to this. Complete the following probability table. Complete the following probability table and show that A and B are independent. We know that it is given this is 0.4, we know this is 1, therefore this one is 0.6. Since this is 0.5, this one is 0.5. However, this one is 0.3, 0.3 plus this is 0.2, this is 0.2. What is probability of A intersection B? 0.2. What is probability of A? We know this row. What is it? It is 0.4. What is probability of B? This column, it is 0.5. Therefore, the probability of A times the probability of B, 0.4 times 0.5, 0.2. Now, the probability of A intersection B is equal to the probability of A times the probability of B. Therefore, A and B are independent. In this video, I have discussed the basic concepts of the probability that we want 11 and 12 mathematical methods as well as the IB students and other international exams. Thanks for watching my video. Please subscribe my channel to watch next video. Thank you very much.